So in partial fractions, there's five different types of partial fractions that you can make in a very generalized way. So it's five types. So if you want to make a partial fraction, you're going to have a function somewhere like this or like this. So I'm going to start with this, and let's make type 1. So the first step you're going to do is you're going to factorize the denominator. So in type 1, we're going to get px plus q by x minus a, x minus b. So suppose this is any equation and you get factors like this, okay? So with these factors, what you're going to do is, this is integration, okay? I'm just ignoring it for a while, but we're going to come back to it. So ax, a, sorry, no, just a by x minus a plus b by x minus b. Now you're wondering what that a and b is. They're terms you don't know yet. This is the partial fraction form, but and you're supposed to find out a and b, and since these two are equal, you can just integrate this, and this is going to be easier. Hence, the reason partial fractions are done is just to make integration easier. So that is the first type. Now, obviously, I will tell you how to solve this in the second part. Just let's finish off the types for now in this video. So one, that is type 1. So you're going to get the two different factors, and you're going to give one term for each factor, right? So case 2, you're going to take this function, you're factorizing denominator, and you're getting this, okay? Px plus q by x minus a, x minus a, x minus b. Or to put it simply, it's just going to be px plus q by x minus a whole square, and you're going to get x minus b. So so here you can see you've got a square over here, and when you see that square, you can't do it normally like you do it here, okay? Whenever you see this, what you're going to do is equal to uh, you're going to give a term a by x minus a. There's no degree here, there's only a by x minus a. So for the second term, you're going to do x minus a squared. You're going to do it a second time, but this time you're going to square it. Then you're going to do c by x minus b, because there was an x minus b available. So yes, this. So this is the second type, and as a as in general, I'm going to say, if you're going to see something like x minus a whole cube in the denominator, uh, like for you get something on the top like px plus q, you're going to get something else. So in the form of partial fractions, what you'll get is a by x minus a. You're going to do it once, and then b by x minus a whole square twice, and then c by x minus a whole cube. So you're going to repeat every single degree. And if you get something like that, which you probably won't in CBSE boards, but if it does happen, this is the way to do it. Now for type 3, 4, and 5, we're going to use this form of function. So for, let's start with type 3. For type 3, as usual, you're going to factorize the denominator, and what you will be getting is px, uh, px square plus qx plus r. That will stay in the numerator, by x minus a, x minus b, x minus c. That's a mistake. B, c. You're going to get three different factors, right? This is the easiest of the three from this. So a by x minus a plus b by x minus b plus c by x minus c. That is the easiest form from this kind of function to form into a partial fraction. This is very similar to type 1. You're just taking the extra factor and you're making another term for it. And that's simply how you make this into a partial fraction. Easy. Now, for type 4, we're going to get px square plus qx plus r by x minus a whole square and then x minus b. So what you're going to do here um, is equal to a by x minus a plus b by x minus a whole square. You're doing it twice because, as I told before, plus c by x minus b. I might have made a mistake in type 2. In type 2 is just px plus q by x minus a square. So you'll just do a by x minus a plus b by x minus a square. There was no c, alright? Forget it. That okay. So in type 4, this is a combination of type 1. This is a combination of this and type 2. So you'll to make a partial fraction from this kind of function. This is a way to do it. Now, type 5. This is a little annoying to understand, but once you get the hang of it, it's rather easy. Px square plus qx plus r by x minus a x square plus bx plus c. Now, after factorizing this, and if you're getting something like this, meaning this function here, it doesn't factorize anymore. That's it. So what you're going to do with this is you don't have to worry about this when you find a question like this in the exam. People usually get frustrated because it looks kind of scary, but it's not. Okay, watch this. So you're going to take this, and what you're going to do is a by x minus a, the simplest part of this, easy, plus. Now what you're going to do is, since we see an x square over here, the degree is 2, you're going to merge terms b and c, because uh, suppose for this you're getting two different terms for b and c, right? Since if you multiply this, you'll get x square. So we're going to merge the b and c terms, since here if we multiply these as well, you're supposed to get x square. You're supposed to. So here you're going to get bx plus c by x square plus bx plus c. So you're merging terms 1, b and c, to get something like this. And that is the partial fraction for this kind of function. Now, obviously, these are all integration dx, integration dx, integration dx. But yeah, to do the actual procedure, I'll get it in the other video. But yes, those are the 5 types to know.